Did you know your head ages just a bit faster than your feet? It's a tiny difference, but it's real. An invisible effect happening to you right now, every moment you stand upright on Earth. It sounds wild, but it's a real effect, one that reveals the true nature of time. This strange phenomenon is a clue that time itself is not as simple as we once believed. Every second, a tiny difference in the flow of time occurs between the top of your head and your shoes. Gravity, ever present, subtly, stretches and compresses time itself. Time isn't a steady universal clock. It bends and warps, depending on where you are and what surrounds you. It's more like a river, its current shaped by gravity. Sometimes it rushes, sometimes it slows, always flowing but never quite the same. We mark our lives by time, assuming a second is the same everywhere. But in reality, every clock in the universe ticks to its own rhythm, set by the gravity around it. But the universe has a secret. The flow of time isn't uniform. It's a hidden current, always shifting, always changing. In deep space, far from any massive object, time rushes forward, almost unimpeded, racing ahead at its fastest pace. Near massive objects, it slows to a crawl. The stronger the gravity, the slower time moves, as if caught in a gentle but relentless grip. To understand this, we must let go of our everyday assumptions and see the world as a four-dimensional reality. Space-time. Here, space and time are woven together, inseparable and dynamic. This concept is the key to unlocking the mysteries of gravity and time. It's the doorway to a deeper understanding of our universe. Our journey begins with gravity, the force that keeps us grounded in planets in orbit. It's the invisible hand shaping the cosmos and the passage of time itself. But gravity is more than just a force. It's the conductor of time's symphony, orchestrating the tempo of every moment, everywhere. Albert Einstein gave us new eyes to see the invisible connections between space, time, and gravity. His insights changed our understanding forever. He revealed that time's steady beat is actually a symphony, its tempo set by the gravity of stars and planets, each note shaped by the universe itself. So let's ride this cosmic river from Earth to the edge of a black hole, where time's flow becomes truly extraordinary. The universe is far stranger and more wonderful than we ever imagined. Its secrets are waiting for us to explore. And it all starts with the way gravity shapes the flow of time, guiding us on a journey through the unseen river that connects us all. What is gravity? It's a question that has fascinated humanity for centuries, inspiring wonder and curiosity in people of all ages. For generations, we thought of it as the mysterious force that makes things fall to the ground, from apples to everyday objects. Isaac Newton described gravity as an invisible pull between masses, stronger when objects are massive, weaker as they move farther apart. His law explained why we stay anchored to the ground, why the moon orbits Earth, and why planets circle the sun in their endless journeys. For over 200 years, Newton's vision reigned, gravity as a predictable force, space as a grand stage, and time as an absolute, ever-ticking clock. But Newton's theory had cracks. The orbit of Mercury, closest planet to the sun, didn't quite fit the equations. Astronomers searched for answers, proposing new ideas and searching the skies, but the mystery lingered, a clue that our understanding was incomplete. Gravity is the architect of the universe, sculpting galaxies, igniting stars, and choreographing the elegant dances of planets and moons. On Earth, it shapes the flow of rivers, the rise of mountains, and even the structure of our own bodies. Our bones and muscles are built to resist its constant pull, adapting to the force that grounds us. Gravity isn't just what makes things fall, it's the organizing principle of the cosmos, connecting everything from the smallest pebble to the largest galaxy. It shapes everything, from tiny grains of sand to superclusters of galaxies spanning millions of light-years. But to truly understand gravity, we needed a new perspective, a way to see beyond Newton's laws. That revolution was about to begin, promising to transform our understanding of the universe, and it would change our view of the universe forever, opening doors to new mysteries and deeper truths. In the early 20th century, Albert Einstein reimagined gravity, forever changing the way we understand the universe. He wasn't satisfied with the idea of a mysterious force acting at a distance, as Newton had described. Through imaginative thought experiments, like falling elevators and chasing beams of light, Einstein reached a stunning conclusion that would upend centuries of physics. Gravity, he realized, isn't a force at all. It's the curvature of space and time itself, shaped by the presence of mass and energy. Space and time are woven together into a single, four-dimensional fabric, space-time, where every object leaves its mark. Mass and energy bend this fabric, just as a heavy bowling ball warps a stretched rubber sheet, creating curves and dips. Planets and stars create these dips in space-time, and objects naturally follow the curves. No invisible ropes or mysterious forces required. The Earth doesn't pull you down. Instead, it warps space-time beneath your feet, and you move along the curve it creates. The Earth orbits the Sun for the same reason, following the curved path carved out in space-time by the Sun's immense mass. This was a paradigm shift. Gravity as geometry, not as a force, and it changed the very foundation of physics. And if space and time are one fabric, then bending space also bends time, linking them in ways never imagined before. Massive objects warp both space and time, stretching and squeezing the very fabric of reality. Time is no longer absolute, it's relative, shaped and stretched by the presence of gravity. Where gravity is strong, time itself slows down, ticking at a different pace than in weaker fields. Einstein's vision shattered the old universe and built a new one, where space and time are dynamic and alive. The pace of time depends on where you are in a gravitational field. On a mountain, in space, or at sea level, clocks tick differently, and that changes everything we thought we knew about the universe, opening doors to new mysteries and possibilities. Picture space-time as a vast, invisible grid, 3 dimensions of space, 1 of time. Everything moves through this 4-dimensional landscape, even when you're still. Sitting still, all your motion is through time, 1 second per second. Einstein's relativity says everyone travels through space-time at a constant speed, the speed of light, spread across space and time. Move through space, and you divert some motion from time, so your time slows down. The faster you move through space, the slower you move through time. This is special relativity's core. Time isn't absolute. General relativity adds gravity mass curves space-time, forcing you to change your path. Standing on Earth, gravity pulls you down, and the ground pushes up. This struggle is your weight. Gravity's warping of space-time means your time slows down, even when you're standing still. Let's make this real with a thought experiment. Take 2 identical, precise clocks, leave one at sea level, carry the other to a mountaintop. Earth's mass warps space-time, gravity is stronger closer to the center. The sea level clock is deeper in Earth's gravity well. Time flows more slowly there. The mountain clock, farther from the center, is in weaker gravity. Time flows faster. After a year, bring the mountain clock back and compare. The mountain clock is slightly ahead. It's aged faster. This isn't a mechanical glitch, it's time itself passing at different rates. This effect is called gravitational time dilation. Where gravity is strong, time flows sluggishly. Where it's weak, time rushes forward. Your head is farther from Earth's center than your feet, so your head ages a bit faster. The difference is tiny, but it's real. Gravity shapes the flow of time, even within your own body. The universe is truly wondrous. What happens when gravity is pushed to the extreme? Enter the black hole. A black hole is where mass collapses into a tiny space, warping space-time so much that not even light escapes. Imagine watching a friend approach a black hole's event horizon. From afar, you'd see their movements slow, their signals stretch out, and their image freeze at the edge. To you, their time nearly stops. But for your friend, time feels normal. They experience every second. If they look back, they'd see your life, and the universe, speed up. Stars and galaxies evolving in moments. By diving into extreme gravity, they become a time traveler, leaping into the future. Black holes reveal the ultimate power of gravity over time. They are nature's most dramatic time machines. Einstein's ideas were bold, but science demands proof. In 1919, astronomers observed starlight bending around the sun during an eclipse. Just as Einstein predicted, space-time was curved, and the world took notice. In 1971, atomic clocks flown around the world returned out of sync with those on the ground, matching relativity's predictions. But the most practical proof is in your pocket: GPS. GPS satellites orbit high above Earth, where gravity is weaker and their clocks run faster. They also move quickly, which slows their clocks. The system constantly corrects for both effects. Without relativity, GPS would fail by kilometers each day. Einstein's theory isn't just beautiful, it's essential for modern life. The universe really does work the way he said. Why does time dilation matter? Without relativity, GPS would be useless, your location would be off by miles in a day. Relativity is a practical necessity for satellites, deep space probes, and global networks. As we explore farther, our reliance on Einstein's map will only grow. Understanding gravity's effect on time helps us model the universe, from black holes to the Big Bang. It's the key to detecting gravitational waves, ripples in space-time from cosmic events. We're not just observers. We're participants in a dynamic, four-dimensional reality. The fact that we can understand and use these laws is a testament to human curiosity. It connects us directly to the workings of the cosmos. Realizing time isn't absolute is a profound shift. The idea of a universal now is an illusion. Your now is different from someone moving or living in stronger gravity. Every observer carries a personal clock, ticking at its own rate. This opens up possibilities once reserved for science fiction, like time travel to the future. Near a black hole, a year for you could mean thousands pass on Earth. The laws of physics allow it. The universe is a time machine. When you look at distant galaxies, you see them as they were millions of years ago. But time flows differently there too. We're all on unique journeys through space-time. Gravity warps space and time, slowing your personal clock with every second. You live inside a gentle, cosmic time machine. This deepens the universe's mystery and shows how interconnected reality truly is. We are stardust, held by space-time's curve, privileged to comprehend it, and our journey through the river of time continues.